Hello, and welcome to Sprint 3 for Engine 2. In this sprint, I'm going to introduce you into the OBB with the sphere, the ABB, and the OBB, and also the beginning of my state machine. I'm very proud to say that I have got my state machine started. So without further ado, let's get moving. So you saw earlier that I do have obviously my my OBB versus OBB going. I'll show you that. But let's go over here to the cottage and let's change this to B sphere so that I can show you that the OBB and the B sphere do indeed work. So we're going to go ahead and pop this up. Let's zoom out a little bit so we can see this. And you can see here that this is an OBB. And if I go ahead and drive this into the sphere, you can see here that it does register that collision. So you can see in the background I have a fan. And yeah, so he's colliding with that sphere, which is right there. Yep, see. And if I go over here to the OBB, and I go ahead and I boot that up, you can see also that that is working as well. I'll show you the code for that after this. So yeah, right here, and then you can see that OBB, yep, collision right there. Let's go over here and get a better look at this right here. Oops, a little bit too far. Yep, so you can see right here that it does collide. If I go flat but then move it in, it does collide. Yeah, so let me show you the code before I move on to the ABB. The AABB, I'm sorry. So over here, actually I might have it up here. Boop. All right, yeah, right here. So for the first off, I have collision OBB with the sphere, and that's this one right here. So what I do is I go ahead and I grab the min and the max, and then I clamp it to the actual, I invert clamp it to the OBB, and then I multiply it by the world to get it into the world, and then I square the radius, which me and Ian and I were actually arguing about this because in your notes it says to square the radius, but he believes that that's not the case. So it works the way that I do it, so I'm gonna leave it like that. If the distance is greater than or equal to the radius squared, return true. So that's how that works. And then for the OBB, you've seen that. I went ahead and I cleaned it up, and I went ahead with your method at the end. I just returned a bunch of ands, and then up here for the projection max, I do the same thing, just cleaned up a little bit. If we go in here, you can see that. Oops, I have two now, so I have to. You can see that I am no longer doing the math in here for that was the center. I'm sorry, I'm no longer doing the math in here. I'm doing the math up here. So it's computed once per update, and then also the corner and min and the max are also they're received during the construction of the object. So only once before the entire object is made. So I fixed that. Oh no, where'd it go? Right here. So then that's how that works. And then for here, this is the obvious axis, the float epsilon, just in case they're collinear. Yeah, I have the distance formula. Yeah, so that's the OBB and OBB, and then the OBB and the AABB are actually not dissimilar at all. Down here we have OBB and AABB. It's the same thing. It's just, I just made it different so that you knew that one was an ABB and one's an OBB. So if I go over here to the cottage and I change it to an AABB, you can see that when I boot it up and I operate the machinery, whenever it decides to operate, you can see that that it will register collision properly as well. The trick here was that the AABB returns a corner min, corner max that are in the world. You have to return the actual local corner and local max so that it does it properly because of the equation for the for the OBB. Man, there's a lot of them. So moving on. Next up on the agenda. The fleshed out planning document, it's pretty much the same as the last planning document. I haven't really had too much time to iterate on it because I've been spending a lot of time on my state machine. Obviously the math for the collision boxes and spheres for the OBB was a little bit difficult, not overly difficult, but it was a little time consuming. So the rest of the time I spent with my state machine because I did want to give you something that you could see that I was working on this state machine. So if I go over here to the state machine, and now I know you said not to put classes in the same file, so this is kind of just like a prototype. I'm still trying to figure out how I want to separate, because I know it's supposed to be in like an end programmer product. So I'm trying to like figure out the package that I want to like put it in. So for right now, I kind of have this one file thing, and then I also have a state collection where they can, assign their states to that collection. I got some instructions going on for now, but but for otherwise, this is kind of what I have going on right now. I have a search state and an attack state, just kind of like basically implemented in here. I have that was the enemy that you were looking at that was in the background during my my collision demos. Let me go to the enemy wherever he is. Oh, wow, I'm never gonna. I hate when I can't find these things when I need to find them. State machine objects. There it is. Wow, I'm not the smartest man in the world. Basically, you can see here I assign a current state to the address of state collection attack. And how this is pulled off is that actually in the state machine.cpp I have this const attack state, and then down here these are actually in the state collection they're static, so they can be referenced like that. And then in the enemy tank, he down here has a const state machine current state, and then in his in the .cpp I have current state is equal to current state execute this. So it passes the reference to the object that's currently utilizing the state machine. It executes, and then it assigns the next state, which is passed back to the current state. Now, this is just a prototype. I'm not entirely sure how this is going to work, but you can see here that I have a base class state machine, and I have they're virtual consts, and they pass back a state machine. So at the end of execute, it calls get next state, because I don't know why it would be separate. I mean, if you're going to execute, you're going to get the next state too. So why wouldn't you just have execute get the next state for you? And then that passes back, get next state passes back a state machine, which then execute passes back a state machine as well. And then down here you can see that I have attack state and search state. And then if we go in here, we can see that I have just a basic in range, out of range, function going on. And I chose this squared because I figured that'd be cheaper, and then that way I could just square whatever the result is and set this to like a constant or whatever, and then change that if I decide to. But yeah, so I can show you how it's working in functionality. You can see here it returns the address of whichever the next state should be based upon what happens during the get next state thing, whereas execute just does whatever the functionality is supposed to be for that state. So you can see here I'm out of range, and then when I get closer, I'll automatically switch to in range, and then when I move back, it'll go back to out of range. So right now it has two states. It has the attack and the search, and right now it knows that I am in range, so it's attacking me. Let's move a little bit closer so we can see this. So right now it knows that it's attacking me. Now it knows it has to search for me. Now it knows it has to attack me. And now it's going to search for me. So that's kind of how that's working for that. That's my project for now. This has been a very long video. Thanks for hanging in there. And I will see you tomorrow.